All right, everybody, hello and welcome back. Today what we're going to do is we are going to work on writing exponential equations from points. Now, in front of you, you have a table here that we're going to take a look at, and now we are going to start with something we're a little bit more comfortable with. So many of you might realize that our pattern here is we are increasing by 3 every time. So that is not an exponential, that is going to be a linear function, because our y values are changing by the same amount every time, and so are our x values. So here what we can see is we have change in y, which is 3, divided by change in x, which is 1. So our slope is going to be 3 over 1, or just 3. Now, because this is a linear function, we know that it's going to be of the form y equals mx plus b. Our slope we just found to be 3 times x, and our b value is going to be the y value when x is 0, which in this case here is 11. So it's pretty easy for us to write a linear equation based on points because it's something we're comfortable with. We are familiar with linear functions, and we're going to apply the same thinking to exponentials. Now, this next example is a little bit different. Many of us will quickly realize that the pattern here between our y values is that we are multiplying by 2 every time. Our x values are all increasing by 1. And so we're going to use the same approach as we did before, except because this is exponential, the equation we're going to want to write is going to look like this. Y equals a times b to the x power. Now, all we're really going to need to do is plug in our rate, which is b, and we're going to have to find an a value that's going to make this true. Now, if we know what we're looking for, it's pretty easy given our table. However, if we want, what we can do is pick any point from our table, such as this one, 1, 4, and plug it in. So we'll get the y value is equal to a times b to the x. So 4 is equal to a times 2 to the first. If we just simplify and solve here, we can divide by 2 and divide by 2. We get 2 is equal to a. So our equation is going to be y equals our a value, which is 2, times our b value, which is also 2, to the x power. This is the exponential equation for our table listed above. Now, it's a coincidence that our a and b values are the same, but we're going to use the same approach in our next couple problems. These ones, however, are going to be a little bit different. So it says write the equation of an exponential that passes through the points 224, 3, 144. So this one's a little bit different because we are only given 2 points. But we are going to use kind of the same idea we did here to figure out what our rate might be and what our a value is going to be. So we know this is exponential because we were told that in the problem. So the equation we're going to use is this. Now, what I'm going to do is I'm going to plug in one of my points. It doesn't really matter which one, so I'm just going to start with the easier one with the smaller values. My y value is equal to my a value times my b value to the second power. Now, we can't exactly solve for any of our variables to get a specific number because we don't know what a and b is. There are 2 unknowns in this problem. So instead, what I'm going to do is I'm going to isolate one of my variables. So I get 24 over b squared is equal to a. What I want to do next is I'm going to take that same equation from before, and I'm going to plug in my next point, this one here. So my y value is equal to my a times my b to the x power. Now, we previously solved for my a value, so I can go ahead and substitute that in, which will allow me to have an equation here that only has b values. Now, the reason that is helpful is now because it's all the same variable, I can solve for b. So I'll get 144 is equal to, since this b to the third will join my numerator, I'm going to have 24b to the third divided by b to the second. Now, when we have something in the numerator and denominator that has the same base, we take their exponents and we subtract. So 144 is going to be equal to 24 times b to the first. Lastly, I'm going to divide by 24, and I get 6 is equal to b. So now that I know what my b is, I can plug back in to my equation from before to solve for a. So if 24 is equal to 6 squared, which should equal a. Well, that's really just going to be, and I'm running out of room a little bit, 24 over 36, or 2/3 is equal to a. So now I know what my a is, I know what my b is. What I can do is write my equation. My equation is going to be y equals a times b to the x power. And that's essentially how we're going to tackle all of these problems. So let's do one more just so we can get a little bit more practice. And now we're going to throw in some negatives. So sometimes negatives give us a little bit more of more difficulty. So I just want to give us an example here so we can practice just to see what it looks like. So again, write the equation of an exponential that passes through the points, negative 432 and negative 2, 2. So again, we're going to start off with our equation. And I'm going to plug in one of my points. Y equals a times b to the negative fourth power. Now, when we have a negative exponent, we can get rid of it by moving it to the denominator, if it's in the numerator, or from the denominator to the numerator, if it's already in the denominator. Essentially, we just need to remember that this is over 1, and so now if we just move the b to the bottom, the exponent is going to become positive. So if I isolate my variable, I'm going to multiply both sides by b to the fourth. I get 32 b to the fourth is equal to a. So a little bit different than what we had before, but the same rules are going to apply. I am now going to plug in my next point. Y, which is actually 2, equals a times b to the negative second. I can substitute what a is equal to. 2 equals 32 b to the fourth times b to the negative second. When we are multiplying two values that have the same base, we're going to take their exponents and we are going to add them. 2 equals 32 times b to the second, and now I can solve for b. So I'm going to divide by 32, divide by 32. We get 1 over 16 is equal to b squared. And to get b alone, right, we just want to solve for b. I'm going to take the square root of both sides. Now, in this example, it's going to complicate things a little bit because whenever we take the square root and we are solving, we need to remember that we are going to need to include a plus and a minus. So that means the square root of 1 over 16 is going to be plus or minus 1 over 4, and that is my b value. Now, because I know what b is here, I can substitute back in to solve for a. 32 times, here's the interesting part. Because b is to the fourth power, even if it's a negative 1/4 or a positive 1/4, because we're going to the fourth power, it is going to be a positive. So a will be positive. So I can essentially just plug in, I'll just plug in 1 over 4 plus or minus to the fourth power equals a. 32 times, well, 1/4 to the fourth power is going to be positive 1 to the fourth is 1. 4 to the fourth is, well, 4 times 4 is 16, times 4 is 64, times 4 is 256. Let me double check that. Yes. And now if we take 1 over 256 and we multiply by 32, we get 32 over 256 is a, or if we simplify that, 256 divided by 32 is 8. A is going to be 1 over 8. So my answer here is going to be y equals my a value times my b value. Again, in this case, we want to include the plus and the minus because we don't have enough information to know if this is going to be a positive 1/4 or a negative, given that we only have 2 points here, and we're going to raise this to the x power. So this is our solution here. That plus or minus might give some of us some difficulties, but it's a little bit unique depending on our situation. So this is basically how we're going to do all these problems. We are going to start off with what we know to be the form of exponential functions. We plug in one of our points so we can isolate a variable, and then we'll plug in our other point and substitute what we got for one of our variables so we can solve. Once we solve, we plug back into our first equation to get both variables, and then we plug in and get our equation. Okay? As always, thank you for listening. If you have any questions or concerns, please feel free to reach out.